How's it going, guys? In this video I'll solve one of the Leetcode programming questions. It's called two-sum problem. So let's get started. In this video I'll solve the problem in two different ways. One is a simpler one and has a slower solution, and it's a little bit easier, versus the second one, which is a little bit more complex, but it's faster in terms of time complexity and running time as well. So let's get started. Let's understand the problem first. Basically what you have to do is you have an array and a target, and you have to figure out two numbers inside that array that sums up to that target. So if you can see in this example, the array is 2, 7, 11, 15 and the target is 9, and you have to find out two numbers that sums up to that target. So in this case 2 and 7 sums up to 9, which is our target, and hence we have to return the index 0 and 1 of those items in the array. So my first solution is using the brute force attack. Now I've changed the question a little bit, or my example a little bit. So you have the same input, but your target is 13. So basically what you can start with is you can iterate through the array twice and in a nested for loop, and then you can check if any of the indexes matches up or sums up to the target. So you start at index 2 and you have a nested loop that traverses the whole array twice. So you start with 2, then you go to 7, and then you see if it sums up to the target 13. In this case it doesn't. So you move on to the next index. So you see 2 plus 11, does it sums up to 13? And yes, it does. So you found your number and you can simply return it. So I'll write a code for this and let's get started. So basically I can take my pseudocode and then start writing the code. So I can start int I equals 0, and then this will do the first loop inside our method, and then since it's an array, so it's not a method but a property. So we start, and then I start my nested for loop with j, let's say, and then I plus 1. So if you see, I start with the next index. So instead of starting with 2 again, I start with the next index, so that it doesn't do any duplications. And then nums dot length, and then this should be j. So this is the nested for loop condition, and we see if nums at I plus nums at j, it matches up to our target. So if it does, then we found our number and we can return it. So we need the index, right? So we can return the array in as an index, and if we didn't find our number, then we can return 0 0, just to show that we didn't find our number. But this should never happen, because the input says that there is exactly one solution always. So that's our brute force solution. Let's run it to see if I did any syntactical errors, and seems like I did not. So I'm gonna submit it and go ahead, and it does work. And if you see, it has a pretty good time complexity and runs pretty fine. But what if your interviewer asks you to enhance this solution or make it better? So can we really do anything better than this? And the answer is yes, we can. To make it better, we have to use a better data structure than array, and then we have to eliminate that for loop, because if you see the time complexity of our first solution, it's big O n square, where n is the length of the array. So it traverses the array twice on an average case, or no matter what the size of an array is, it has to traverse it twice. We can do this better than the current solution using something called HashMap. So basically what you do is you take the current number and find the difference between the target and the current number, and you see if the difference is already in the HashMap. Now what this will do is this will eliminate the nested for loop. Let's take a look at our pseudocode for our optimized solution. In this solution I'm going to use HashMap instead of arrays, which will give us a searching time complexity of big O n, and that's why HashMap is used a lot of time, because it can search elements inside HashMap in a constant time. So here's how our algorithm looks like. What we do is we traverse the entire array, and every time we traverse we find out the difference between the current element and the target. So we do 9 minus the current element, which is 2 in first case, and then we see if that element is inside our hash map. If it is not inside our hash map, then we simply add the current element, not the difference, but the current element inside our hash map, because that's what we need to find now. And then we move on to the next element, which is in this case is 7. So last time we added 2 in our hash map, we find out the difference, which is 9 minus 7, which turns out to be 2. And then we check again if it is in our hash map or not. In this case it would be in our hash map, and we found our number. If it doesn't, then the number is then our algorithm is wrong. So let's test it. So I will revert this to the original one, and then basically what we need to do is first import hash map in Java. So we can do java.util.asterisk. We can specifically import hash map as well, but in this case I will quickly import everything from Java util class, and then I need to declare a hash map of type integer, because we are working with integers. And then I'll limit hash map, I'll name it map, and then I need this as well, and that's our declaration. So we start looping our index or our array, and then we use nums.length property to traverse our array. And then first thing we need to find out is difference, and then we check if the difference is in our hash map. If it's not, then we add the current element. So let's find out the difference first. So the difference is target minus the current element. So target minus num set I, this will return the difference. And then we need to find out if this difference is in our hash map. So we can do map dot contains key, which is a method in hash map to determine if the key is in our hash map or not, and the time complexity of this is big O 1, and that's why we use hash map. And then we check if difference is in there. So if the difference is in there, then we have found our number, and then we can simply return it. So we can do return new int, and then map.get, because we need our current index or the index of the item. So map.get difference, and then the current iteration, so the index of current element. And if it is not there, then we do map.put, we add the current element and the index of it in our hash map. And if there is nothing found, which should never happen, then we should return 0 0, just to make sure we are not doing anything wrong. And I need a semicolon here. So let's see if I did any syntactical errors, and looks like I did not. So let's submit the solution and check. And if you can see, the runtime of this is 2 ms, which is 98% better than all of the solutions on Leetcode. So that's my solution for the two-sum problem. Hope you enjoyed this video. If you did, then maybe browse my channel and see if there is anything that you like. Please do like and subscribe to my channel. Thanks for watching.